question before, it's minus 5 over 64. Let's have a look at some harder examples now then. So the second term of a geometric sequence is 4. The second term, so it's in the form, isn't it? AR to the n minus 1. So it would be like this. The second term is 4. Okay, the second term, they all start with this first number a, and it has the ratio applied n minus 1 times. 2 minus 1 is 1. Okay, the fourth term is 8. So the fourth term, again, n minus 1 is 3. The fourth term is 8, and find the ratio first. So there's a couple of ways you could do this. One, you could take this equation here on the bottom and you could divide it by the top one. You could do something like this, and cancel, that will cancel and it will go down, that will be removed. So you can say r squared equals 2, r equals, plus or minus root 2. The common ratio is positive, so the common ratio is positive, so it's going to be just positive root 2. That's one way you could do it. Sometimes it's useful to sort of do it as a timeline, as a bit of an illustration. So you could sort of say, well, there's the first term, and then it's 4, and then it's something, and then it's 8, and you can sort of think, you know, how many times is it multiplied? Once, twice. So r squared equals 8 over 4 is another way you can think of it. What's the first term then? Well, we know that the second term is 4, so to go backwards we'd have to divide. So it's going to be 4, let's make some space, it's going to be 4 divided by root 2. And if you rationalize that, what will you get? Well, you'll get 4 root 2 over 2. So that's going to be 2 root 2. Okay, so let's write these key terms down. So a equals 2 root 2, r equals root 2, and hopefully you should see that makes sense to get 4. So what's the 10th term? Well, we're going to do, so the n minus 1 is 9, so let's put these numbers in. It's 2 root 2 times root 2 to the power of 9. And again, you can just sort of chuck that all in your calculator. Let's just check the answer. What are we supposed to get for this one here? We're supposed to get 64. Okay, which sounds reasonable. Next question then. So a harder question. Let's have a look. The numbers 3x and x plus 6 form the first 3 terms of a positive geometric sequence. So let's do a different color pen. The first term, I'm just going to say the first term is 3 because that might be useful later. So if we think of it sort of like a line as in the sequence, it looks like this, doesn't it? So whatever you multiply 3 by to get to x is the same thing that you multiply x by to get to x plus 6. So the secret here is that the relationship between x and 3, and we're going to do a division because this is about multiplication and division, a geometric sequence. Whatever the answer is to this, whatever the ratio between the second and the first term is, will be the same as the third and the second. That's why they give you 3 terms. So we end up with this. We cross multiply, we get x squared equals, let's just do that in one go, 3x plus 18. We factorize this as a quadratic, and we get x plus 3, x minus 6 equals 0. And it says positive in the question. It says they form some positive sequence here. So what is x? X must be minus 3 or 6, but this is a positive sequence, okay? So it's going to be 6. It's not going to be minus 3, otherwise it wouldn't create a positive sequence. So we have A equals 3, so it goes 3, and then it goes 6. What's 6 plus 6? It's 12. Okay.